You won't believe what just hit the AI world. Out of nowhere, a new model has shaken the foundations of what we thought was possible. It's breaking all the rules, being twice as fast, far more intelligent than most of its predecessors, and here's the kicker, it wasn't even trained. No, seriously, there's no massive GPU grind, no new data collection, nothing. Instead, it's using a mind-blowing technique called assembly of experts, which takes the best features from multiple AI models and combines them into one insanely powerful entity. The result? A next-gen model, DeepSeek's R1T2 Chimera, that's faster, smaller, and more efficient than anything we've seen before. And it could very well be the future of AI. Here's how they pulled it off. Section 1. The birth of DeepSeek's R1T2 Chimera, a game-changer in AI efficiency. You're looking at a language model that brings together three powerhouse predecessors, R10528, the original R1, and V30324, into a single AI brain that not only thinks faster, but also processes information more concisely. The secret sauce? Assembly of experts, AOE. Now, most of us are familiar with the typical process of improving large language models. You gather new data, spend weeks training them on powerful GPUs, and hope the new model doesn't overfit or hallucinate. But AOE throws that entire playbook out the window. Instead of retraining everything from scratch, the engineers at DeepSeek simply pull the most crucial weight tensors, think of them like tiny switches controlling how the AI works, from each of the parent models. They then blend these tensors into one unified model without the need for excessive training. Simple math, no fancy backpropagation, just straightforward tensor algebra that any decent computer can handle while you grab your coffee. And this makes everything run faster and more efficiently, about 18 times cheaper to operate compared to a traditional model using all of its settings all the time. Imagine a 671 billion parameter brain, but instead of using all of it, it only activates 37 billion for each task. The result? The Chimera is fast, precise, and incredibly cost-efficient. Section 2, speed and performance. Is this the future of AI? Now, why does R1T2 feel so different? The primary reason is speed. Benchmark tests show that Chimera produces answers roughly twice as fast as R10528 and 20% faster than the original R1. How does this magic happen? Two major factors. First, the expert modules from R1 keep the deep reasoning routines intact, ensuring the model still delivers high-level intelligence. Second, V30324's shared layers, optimized for concise and clear responses, keep things short and sharp. When you combine the deep thinking from R1 and the precision of V30324, you get an AI that thinks like R1 but responds like V3. This means that responses use fewer tokens and therefore require less GPU time. The result? Lower operational costs for anyone running this model on a large scale. But don't get too comfortable. Speed isn't the only thing that matters here. Section 3, fear of sacrificing quality? Think again. People have been asking the same thing. Won't merging these models compromise quality? It's a valid concern. And to answer it, the engineers at TNG put the DeepSeek's R1T2 Chimera through every test they could find. They hit it with MT Bench, a language proficiency test, and it scored almost exactly like R10528. On deep factual recall exams like GPQA Diamond, Chimera showed it could hold its own, outperforming both parent models in certain areas. But here's the kicker. On highly technical math challenges, like AIME 2024 and 2025, the Chimera model didn't just keep up with R1, it sometimes even outperformed it. All of this, while reducing the length of answers and cutting down on unnecessary information. This model doesn't just produce short answers, it produces smarter answers, more efficient and more direct. Section 4, how small tweaks lead to big shifts in AI behavior. Here's where things get truly fascinating. When the team slightly adjusted the proportion of R1 in the mix, they noticed something unexpected. As soon as they pushed past the 50% mark, Chimera began displaying the same deep reasoning behavior that R1 was trained for. If they dialed it back slightly, those behaviors vanished. It's a little like tuning a musical instrument. You only need to tweak it just right, and suddenly the model starts behaving in specific, consistent ways. This also reveals something crucial. Those small, nuanced behaviors are locked in very specific parts of the model's massive 671 billion parameters, and AOE allows you to access them without breaking the model. This isn't just smart AI, it's scalable, and it can be molded to your needs. Section 5. DeepSeek's approach: efficient, scalable, and ready for real-world use. So how did DeepSeek hit the sweet spot? By focusing on R1's expert reasoning layers and leaving the rest, like the shared and routing systems, from V30324 intact. The result is a model that keeps R1's superior thinking power while benefiting from the efficiency and clarity of V3. With that configuration, the team released DeepSeek R1T2 Chimera under the MIT license, and within just a few weeks, it was already processing billions of tokens every day. It's no longer just an experiment. It's a proven, scalable AI solution that's ready for real-world use. Section 6. The ripple effect: how this change could affect the AI ecosystem. The reaction was swift. Early users in the Reddit community praised the model for its speed, clarity, and fewer hallucinations compared to its predecessors. Developers especially appreciated how it could handle complex, math-heavy tasks without losing the chain of reasoning. And let's not forget the hardware efficiency. The engineers tested Chimera on two very different hardware setups, NVIDIA H100 and AMD MI325X, and on both, Chimera drastically outperformed the original models in latency. This means businesses don't have to wait as long for answers, and with latency dropping, they'll save a ton of money. Section 7, a new frontier in AI development, the future of model merging. Now here's the exciting part. AOE isn't just a DeepSeek-specific innovation. It's a system that could revolutionize the entire AI ecosystem. Imagine taking 2 or 3 open-source models, each excelling in different areas: vision from one, math from another, and code from a third, and merging them into one custom model that suits your exact needs. You no longer have to wait for the perfect pre-trained model to be released. Just grab some expert tensors, stack them, and you're good to go. It's an incredibly efficient way to build AI without reinventing the wheel each time. For developers, this means lower costs, faster responses, and fewer headaches. It's the future of AI, and it's here right now. Section 8. Conclusion: why this could change the way we think about AI forever. So, there you have it. The new Deeps R1T2. Chimera isn't just a leap forward in AI technology, it's a revolution. Faster, smarter, more efficient, and cheaper than anything before it, and it opens up a whole new world of possibilities for AI development. If you're a developer, researcher, or just an AI enthusiast, this model isn't something you'll want to miss. The best part, you can access it for free thanks to the MIT license. So, what are you waiting for? The future is here, and it's more accessible than ever. Outro. If you have questions, ideas, or want to try your own AI model fusion, drop a comment below. Don't forget to subscribe, and I'll catch you in the next one.